All right. Hello, everybody. Welcome to TGIK 97. We're getting kind of close to 100. Happy Friday. My name's Josh. Those of you who haven't seen me before or seen any of the episodes that I've done, I tend to be the filler for Joe and Duffy, which I love. So it's great to be here with you all. As you're joining in, if you're comfortable, feel free to say hey in chat and where you're signing in from. I'm out of Boulder, Colorado, by the way. So we're kind of in that stage of kind of wintry, but also kind of summery. It's high elevation, so it tends to vary quite a bit. So let's see, who do we have joining us so far? Olav from Denmark. Awesome. Welcome, Olav. Joy from Richmond. Thanks for joining us. Peter from Spain. Very cool. Maddie, welcome. Glad to have you back. Christoph, Germany. Welcome, Christoph. Thanks for joining us. Hey, Peter, San Diego. Welcome. Jacques from New York City. Yeah, awesome. Welcome. Thanks for joining us from the East Coast there. I know it's a little bit later in your day than ours. Jose from Madrid. Welcome. Christian from Germany. Steve. Nice to see you, Steve. Steve used to be on our direct team with Duffy and I, but he's moved on to some more engineering focused tasks. It's great to see your face again, Steve, even if it's just a little thumbnail. Mithil, San Francisco, welcome. We've got Prasad from Switzerland. Very cool, welcome. Ilko, hopefully I'm saying that somewhat close. Welcome from Holland. Sandeep from Poland. Welcome, Sandeep. Great to have you with us. Martin from the net. So does that mean the internet? Welcome, Martin. Glad to have you. Gustavo from Chicago. Welcome. Shahar from Atlanta. Awesome. Welcome. Alski from Russia. Hopefully I'm saying that one somewhat close, but welcome from Russia. Awesome. How's the weather in Russia right now? Is it cold? Is it warm? Martin, Netherlands, welcome. David from Minnesota. Cecilia from Germany. All right, cool. So welcome everyone. I'm sure we'll have more people join as we go. I'm already excited to see the representation from all over the world. Tama from Romania, welcome. Super excited to have you. So in normal TGIK format, we'll start off here by just talking a little bit about some news stuff in the community. And by the way, I've got George joining me. You all probably saw he linked the notes for the HackMD as well. He's going to be helping out in chat here, so thanks so much to George for the support. And let's go ahead and talk a little bit about some news. So in the notes, and I'll pull it up on my screen here and switch over for you all. So there we go. Cool. All right, so again, episode 97, our focus this time, make my camera a bit higher maybe, there we go. Our focus this time is around cluster autoscaling. And autoscaling, as you probably know, has multiple facets to it. We're mostly focused on cluster autoscaling, I guess, but really the other facets of autoscaling play together. So we'll be talking about a lot of the different pieces overall. I'm actually really excited about this topic because this might surprise you. My role, along with Duffy's role, is we help a lot of companies and large orgs implement Kubernetes. And for me personally, I've consulted on and talked about like scaling methodologies in HPA and cluster autoscaler, but it's actually been a really long time since I've touched it, like actually tried to deploy it, tried to use it. Back in like the Cube 1.6 days or something like that, we deployed it to Amazon with a customer I was working with. In fact, we're doing some auto scaling stuff that also like integrated with Spotinst to make like bids on different instance types and stuff. So I'm really excited to kind of revisit this and mess around with it. I expect a lot to potentially go wrong as we're playing around, but it's kind of the joy of it, right? Very cool. So before I get into the news, let's see who else we've had join. Cool. I think I may have said everyone so far. So let's talk a bit about some news. Now, News this week, I guess it's like a fairly lighter week maybe. We've got the beta release for Cube 1.17 is live, so you early adopters and testers, check that out. Download the binaries, mess around with it, give feedback. And then code freeze for those of you who are maybe in like SIGs and working groups is coming up on November 14th, so just be cognizant of that. We have a couple interesting things coming from around the web this week. So inside of our show notes, we've got a link to an interesting project called Chaos Cube. And I've seen certain projects like this propagate. I've seen a lot of my customers I work with, frankly, build this from scratch over and over again. But Chaos Cube might be an interesting project to look at if you're looking for something that can go in and provide some intentional instability to your platform, right? Go in and kill pods and make certain events occur so you can ensure that your workloads on Kubernetes are as resilient as they should be. So this would be one to check out. I haven't personally tested Chaos Cube yet, but definitely a growing area, which is doing chaos engineering atop of Kubernetes. GoDaddy open sourced their Kubernetes gated deployments tool. I like the name because it is extremely specific, right? But basically, from what I've read, and I haven't tested it yet, it looks like a way to do kind of automated and more elegant kind of A/B, canary style testing where you can do some amount of introduction of an app behind a service that might be a new version of the app. And as many of you know with Kubernetes, we can validate that new version works. And if it does, we can make sure that all new traffic propagates into that new version of the app. And I, again, haven't dug super deep into it, of course, but I would imagine that there are, rollback and those types of things built into this system as well. So kind of an interesting one, especially if you're not already like completely bought into service mesh land and you're not already trying to do this with, Istio or Linkerd or something. This could be a pretty interesting thing to check out. Cool. Another one that was really cool that I was reading through, George posted inside of the SlackMD that I thought was really, or HackMD, that I thought was really cool was the Java in a container resource allocation guidelines. So, some of us are really lucky and we live in a place where we just create a statically linked binary and we put that in a really minimal container and then we ship it and that's it. But reality is, most of the world is not doing that. Most of the world's using, most is probably fair. Like most people are using some type of runtime along with their application, and the JVM is an extremely common one, of course. I mean, we all know the JVM is here to stay for a very long time, right? So this talks a little bit about just some general best practices you should consider when running the JVM, right? Inside of a container, I should say. The common things that I've seen customers run into so much, like you don't want to go in and set your heap space explicitly on a JVM level. You want your Java application to be able to respect the limits that you set up inside of the container, right? Because you don't want the multiple levels there to conflict with one another. There was a really interesting one too about some parameters that you can set on it around min and max RAM usage. Particularly, an interesting point is that by default, the JVM heap gets 25% of the container's memory. And if you want to not explicitly go in and set the JVM parameters to explicitly set the memory sizes, you can go in and set the percentages relative to what would propagate from the limits, if that makes sense, right? So kind of an interesting one. If you play in the Java world, or maybe you do Kubernetes and there's Java teams, Java shops in your organization, this might be a really cool one to kind of look at. It's always interesting to get into the weeds. For me, again, to get out of my world of statically linked binaries and so on. So that's really cool. This is one that we're really excited about. Of course, selfishly, Steve's on the line right now. So congrats, Steve. I know you've been putting in work both historically and currently to Contour. So Contour is an ingress controller that is based, well, I should say it integrates with Envoy. It uses Envoy as the technology to actually send traffic into pods. That has finally reached 1.0. One of the kind of unique things about Contour, for those of you who haven't checked it out, is it leverages a CRD that allows you to express really common traffic patterns that you might need to. An example of this that I oftentimes give, and this is mostly just, giving myself some crap because I used to work on this, is back in the day, a couple friends and myself, we worked on the ALB ingress controller, not the Zalando one, but the one that I think is in SIG AWS now. We worked on that ALB ingress controller. And one of the biggest things we found in the design, and it was pretty nasty, is we needed to extend how ingress worked, right? Because it was great and generic and could be used across providers, but it was limited. Like if we needed to do certain specific things with certificates that the API didn't support and so on. And the pattern we went with, along with a lot of other ingress controllers, is we started bloating a massive set of annotations. Like we had a huge table of annotations, and some of the annotations, I'm sorry to say this to you all, but some of the values of those annotations were JSON. It was totally crazy. So imagine like you've got a YAML key, and then the value of that is some JSON structured data, right? So it's super interesting how it all works out. But one of the cool things about Contour, again, is they kind of got ahead of this curve and did a really good job of defining a CRD, which is now called HTTP proxy. Those of you who used Contour back in the day, you may be familiar with ingress route. And with HTTP proxy, you can do a lot of fancy things in a structured way, a lot of it more advanced forwarding type things and rules around TCP proxying and where to terminate your TLS. Do you want to do it on the pod level? Do you want to do it on the load balancer level, right? It just supports those more intricate configurations. And then, last thing I'll mention about Contour, if you do check this out, is it does have a bunch of really interesting multi-tenant capabilities built in. That's quite neat. Because, a lot of times when you all run your Kubernetes clusters at an organization, you might have like a fleet of ingress controllers that serve most, if not all, the pods and workloads. So it's like a multi-tenant ingress layer, right? So a lot of times you want the ability to make sure that when people apply ingress resources, they're asking for their specific domain name or their specific path, right? Or maybe it's TLS stuff, and you want to make sure people are using only their certificates, right? When they set up their ingress resources and so on. So there's a lot of kind of multi-tenant features built into Contour that help you solve those types of problems. So super psyched to say that it's 1.0. Great job, Contour team. Steve on the line too. If you've used Contour, give them a congrats, because I know they put some blood, sweat, and tears into that thing, and it's really, really cool. And then the last, I guess I have two more small pieces of news. Scaffold is GA. I'm not gonna lie, I haven't gotten the chance to use Scaffold yet, but I think conceptually it's a great idea. Anything to help make the developer experience atop of Kubernetes more straightforward, I am a massive, massive fan of. So check out Scaffold if you haven't yet. It's GA now, so if you're kind of thinking about like the DevX experience around Kubernetes, this could be a cool project to evaluate and see what it can offer for you. And then the last chunk of news I've got for y'all on this lovely Friday, one that I'm kind of excited about. It's kind of more of a directional thing, I guess, but there was a pull request that got put in, and I haven't looked into it in super great depth, but it looks like we're starting to do some work to make namespace deletion, or at least the things that are happening behind the scenes when a namespace gets deleted, more elegant. Now, again, I'm not going to commit to whether this exact pull request helps significantly with that, but a lot of times what I've seen is, when you go to delete a namespace, there's a lot of these controllers that are operating on things, and the controllers that are operating on things will see that the namespace is deleting, or at least they'll get an error because a namespace is being deleted, and then get into some kind of cycle, and there's some weirdness, and it can either like slow down the namespace creation altogether, in my experience. It can cause extraneous events and logs to happen in your kube system, or it could even like block it, has been my experience as well. Block the deletion of the namespace. So some of you have done like kubectl delete ns, right? You've probably experienced this to some degree. So it seemed like there was some cool work in here. Again, I haven't dug too deep into it, but basically, from what I could tell, it introduced error type around namespace terminating cause. And then, higher up in the stack, as the clients go through, if it's kind of looping through as a controller and it realizes like, hey, I had an error, and that error was sourced from the fact that my namespace was terminating. from what I've read very briefly in the code before this presentation, it seems like it kind of exits quicker. I'll put it that way, right? So that should introduce a little bit more stability for us long term. I'm looking forward to testing that out and kind of seeing what it has to offer. So yeah, that's it for news. Check out Chaos Cube for chaos engineering stuff. Check out GoDaddy's gated deployment tools if you're interested in doing kind of like A/B-like deployments in an automated fashion. People in the Java world or have consumers of their Cube platform that are in the Java world, check out that runtime resource. Contours 1.0, congrats on that. Scaffold is now GA, and then a really cool pull request on namespace deletion. So let's see if we had anyone else join since I looked last. Ramesh, I don't know if I saw your name last time from SF. Welcome. Super glad to have you. Herman, yeah, thanks. Yeah, we're happy to be using your idea. So shout out to you. This came from a issue in our TGIK GitHub, right? So for those of you who maybe haven't visited it in a while, let's see if I can pull it up quickly here. We do genuinely try to look through and groom these things, right? So if you're ever interested in an idea, if you're interested in Joe and Duffy just like diving deep into some really cool topic that you're interested in, add an issue to the GitHub page here. This is where I got the idea for cluster-autoscaler. I was literally just woke up one morning, grabbed some coffee, scrolled through it, and saw somebody requested, oh, hey, I want to do cluster-autoscaler or want to hear about it, right? And I thought, oh, it's a brilliant idea. I talk to customers about that all the time. So, add tickets in here if you have some ideas. We love the feedback. So cool. Other people we've got in, we've got Philip from Germany. Welcome, Philip. Hamid from Ireland. Jason from my team as well. Jason's also a Colorado person down in Denver, so he's a little bit south of me. Welcome, Jason. Bjorn from Belgium, welcome. And yeah, so, and ABC123, that's a great point. We need to, I guess I wasn't being super honest in the grooming aspect. We really need to, sort our upvotes and see what's getting more traction. That's a great idea. Thanks for that. Awesome. So let's go ahead and frame this discussion a little bit more. Now, again, I don't know if any of you have seen the previous episodes I did like PSPs and network policies, which for some reason, like I've done with almost all my customers, like it's exhaustively written in my brain, right? And this one, like I had mentioned to you early on, is like something I'm interested in. I've talked to customers about, but I just haven't gotten the chance to like do it myself. So I set up some AWS infrastructure for us to test this all out with, and we're just gonna play around and see if we can bring these concepts together. So chat, I would love your thoughts and feedback. Some of you have kind of done this stuff before too, so don't be shy, speak up in chat. I'd love as much involvement as I can. And speaking of involvement, let's start off with a quick question. So my chat people out there, okay? Who has used some type of autoscaling? So HPA, VPA, or cluster autoscaler. So if you want to just put in here for an answer, say, I've used X for one of them, or you could say new to all, or some variation of that. So we'll take a moment here, chat. Kind of give me some background. Who here is totally new to the world of autoscaling in Cube? And then who has used one of these three? Horizontal pod autoscaler, which is HPA, vertical pod autoscaler, and then cluster autoscaler, which is CA. Cool. All right, yeah, okay, some good backgrounds. That's cool, ABC as well on the custom autoscaler based on CPU usage to add more nodes to the cluster. I'll be super interested when we get into scaling our nodes out, kind of how that compares and contrasts with kind of like the upstream approach, if you will. We have a really interesting direction this is all headed, and I'll wrap up this talk with it around like, I don't know if all of you have kind of seen where Cluster API is taking lifecycle management with Kubernetes, but for those of you who know a bit about Cluster API, and I'll elaborate on this, but if we do Cluster API right, and it becomes like the ubiquitous way we manage Kubernetes, it actually has a really interesting impact on how autoscalers can be built. And I'm super excited to kind of brainstorm that with you all. Cool. So yeah, we've got a hugely mixed audience, which is great. So some of you have used HPA. Some of you have just used CA, it looks like. Some of you have used them all. Jacquees, you've got Knative Pod Autoscaler, worked on it a bit. Awesome. Okay, that'll be great. So as we dive in here, feel free to hop in chat and add some context. And if I say something silly, please jump in. Don't hesitate. All right, cool. So we've got a really good audience here. I'm selfishly just excited to play with this. So let's do it, and we'll try to wrap up our Friday on some amount of success. Okay. So couple topics I want to get over. In full transparency, my last couple TGIKs kind of just tried to pack way too much into them, I think. So my thought process, especially with our mixed audience, I'd love to get everyone's expertise here, right? We'll start off with just like scaling at a high level. We'll talk about resource scheduling because it heavily impacts how these scaling models work. We'll get into HPA, we'll get into VPA, we'll get into cluster-autoscaler. Also, it's super interesting that I decided to put the shortened version at the end here, but not here. Anywho, and then cluster-autoscaler. And then we're going to try to bring all of those together because the big thing about autoscalers is, to some degree, they can play on top of each other. Maybe even to what your use case was, ABC. I'm not 100% sure, but the idea that the pods scale, and thus you need the nodes to scale to satisfy the pod scaling, those kind of concepts, right? So we'll dive into that. Now, there's a whole nother world to scaling too, where you can get more intricate, which is integration with super custom metrics and things like that. So I was thinking for this first one, we'll lay the foundation with scaling in general. And then if it's a hit, and if you all like it to some degree, we can have a follow-up session where we dive into integration with metrics you can scrape, Prometheus-like metrics, right? And how you can get more fancy and kind of tuning all of these bits. Cool? So let's dive in. Cool. All right.
Sorry, I don't know that.
Oh wow. Did you hear that? Alexa in my apartment is talking to me. So cool. All right, let's dive in all, and then we'll take it from there. So let's kind of lay out some context here. Now, I wanted to hook my iPad up again so I could draw things with you all. You might have seen some of my more childish drawings that I've done in the past for TGIK, but I lost my Apple Pencil, which is terrible. So I can't do that. So we'll use GIMP, and we'll draw some also child-looking drawings just via this method here. Okay, so just kind of laying the land for us all for just a moment here, all right? So if I kind of come into this green box and we think about scaling as a whole, right? So we know Kubernetes is composed of a bunch of these worker nodes, right? That's kind of a primary principle of Kubernetes, all right? And you might stand up a cluster, and I'd be willing to bet that your cluster has a lot more nodes than my sample one does here. But let's assume that we started off with two worker node cluster, right? So basically, what we're hoping to kind of think about here is, can our cluster be more elastic, if you will, right? So can we take our cluster and, based on scheduling constraints, determine when we need to add more nodes, add more nodes, add more nodes. Now, kind of a piece of this is, of course, the workload component that will drive that, right? So if we think about the workload, again, I told you these drawings would be bad today, but that's okay. These workloads are, of course, the pods. And most of us, we know this super, super well. And the pods can have kind of these carved out values, right? So you've got a pod that can go in, and it could be just deployed. And Kubernetes usually call these deployed pods best effort pods, right? And best effort just implies, I'll throw you on a host where I perceive there's room, use some CPU, use some memory. But hey, if the host comes under contention with other things that have reserved that memory, and potentially CPU is a little more complex, but at least memory, you might get booted, or you might get killed, or something like that, right? So these pods get created, and as the pods get scaled, you end up with the need to kind of create these new pods here, right? Which I will draw, again, poorly, with our dotted lines, okay? So this is our other pod. Now this is a dotted pod because, as you can tell, this box does not fit in our other box, right? So what we would need to do here, if we were just in a one worker mode, is we would need to realize, hey, I am one CPU short, right? So one CPU, all right? Or some amount of memory short or whatever, right? And then the job of a cluster autoscaler, of course, on the cluster level here, is to be like, okay, cool. So you're one CPU short. That makes sense to me. And this cluster autoscaler, while it's kind of like floating in the sea right now, it's in the Kubernetes cluster technically as well, right? It's going to realize that, and it's going to stand up our new worker node, right? So the new worker node comes online, and then theoretically, if it does have at least one CPU of available resources, that pod can simply get scheduled onto that worker node. So this scheduling constraint can go away, and then we can get a pod right here. And that's it. Like on a conceptual level, you're all probably thinking, wow, that was not interesting. That's super obvious. But that kind of sets the stage for what we're trying to achieve here, right? Now, you could imagine, while conceptually simple, there's a whole potential set of challenges, right? There's things like, how do I make sure overnight when my team's Java app freaks out that I don't wake up to a 1,000 node Kubernetes cluster, right? There's things like, how do I make sure that I don't just let someone's pod that's low priority kind of take up all the resourcing as I'm scaling horizontally. Additionally, one thing we hadn't really thought about is like, what's making these pods kind of scale out, right? Because if you think about it, as our friendly users over here, right, kind of send requests into the pods, if we're thinking about like a simple application where traffic comes in, it does something, it sends a response. Well, maybe it's starting to get overloaded, right? And if it's starting to get overloaded, then maybe we can alleviate the load by scaling the pods. So you can probably see where this is going, right? Your pods start scaling. They eventually get to the point, as we saw down here in the bottom, they eventually get to the point where they don't have the available infrastructure to land on. And this is where the CA can kind of take over, okay? So there's one more thing that I just want to throw out there with this diagram too, because it sometimes causes a point of confusion, right? In AWS, as many of you know, you have, let's see if I have my EC2 console still open, I'll show y'all. You have, oh, perfect, auto-scaling groups, right? Okay, so the idea with AWS auto-scaling groups, and this is one of my node pools, right? I've got a min count of nodes right now, which is 1. I've got a max count of nodes, which is also 1, all right? Now, probably not or actually, no, it's 5 right now, isn't it? Okay, cool. So my min's 1, my max is 5. Now, if I were to go in here and set some constraints up, I could say things like, if I reach certain amount of CPU, right, I want to scale my hosts out. I want to add more hosts. And then maybe in reverse, like if I have enough idle, maybe I want to like collapse them to some degree. Maybe you do something similar with other metrics as well. But the thing to make sure you have your mind wrapped around with Kube is that model might not be adequate, right? Because think about this for a moment. If you go into your Kubernetes cluster, right? Let's find our green guy again here. Okay, so just gives me the EBGBs looking at it. It's that bad. Anyways, when you look at your cluster here, your pods might get added, right? And like we may be aware, and I'll talk about, pods have the ability for you to say, give me this much CPU, give me this much memory. It's especially important when you're running, multi-team or multi-tenant clusters. So if you start scheduling a bunch of pods, the scheduler is going to kind of look into Kubernetes and be like, all right, I have room for you here. Okay, this pod wants 2 CPUs and 5 gigs of memory. I carve it out. I place you here. So the scheduler and the controller components, they know about this, right? They can kind of go, okay, cool. I know where you fit in here. But if you just have auto-scaling mechanics at that higher level, like in the case of just an auto-scaling group, you might actually be at capacity, right? But you're not actually seeing the utilization to trigger the scaling event, right? So the example where I'm headed here is you schedule 100 pods, right? And those pods are on average only using 5% of their requested CPU. The scheduler doesn't want to schedule anything new because it doesn't think it has room. But if you look at your nodes, your average node is maybe like 10 to 15% CPU usage, right? So the key thing with these autoscalers is they live in the cluster, right? Like anything else. So the idea is if we deploy this thing, it's cognizant of Kube from an API perspective, right? So it understands if the scheduler is hitting limits. It understands and it knows how to scale based on those things. So that's kind of our high-level overview here, all right? And I'm just gonna take a quick look at chat real quick here. And ABC, we took total ratio of total cluster resource usage, availability divided by the number of nodes in the cluster and scale based on that. Interesting, okay. Yeah, I see what you're doing there. So you'll see obviously a simplified model of that today. I'll be interested once we talk more about kind of cluster API, how that works. And if you can disclose it to ABC, I'd be curious, what's your provider under the hood? Are you scaling on something like Amazon, or is this like internal infrastructure to some degree, like vSphere or something like that? That'd be a pretty interesting piece of data. AWS, cool. Okay, cool. So we're in the same boat. And yeah. Thanks for saying hi to the person. I won't say her name because she will start ordering things on Amazon for me if I do. Okay, so let's take this a step deeper. We've got our conceptual overview here, all right? Our very crude conceptual overview. So the world of scaling, we'll call that good. Now, resource scheduling, all right? So this is where we're gonna kind of start using an example. The first thing that we need to do is we need to have an application that we can use to sort of simulate this right now. So the first thing I want to show you all, I'm gonna move this guy over to 9 and then open up a terminal here. All right, cool. Great. All right, so the first thing I want to do with you all is just have kind of a sample application that we can start playing around with. Now, I went ahead and built some of this stuff out just because I didn't want to waste the majority of this having you watch me stumble through writing Go. So I just wrote a really simple application that will do what we need. But to give you some quick context on the cluster, let's see what we got here. Cool, so nothing has changed from what I can tell. I've got a cluster running in Amazon right now. 2-node cluster, as you can tell by the roles. I've got a master node here, and I've got a worker node, plain and simple. Another thing that we can look at with this data, let me just get that name again, right? Is if you were in Kubernetes and you wanted to know, like, hey, what's available to my node, right? We could go in and we could do a kubectl get nodes. We could ask for this specific node, right? Actually, an even easier version, I think, to look at it is let's just do describe node, right? And NO is just short for node. So if we do describe node, towards the bottom here, you can actually see some of the allocated resources that are available to us. So I think these machines have 1.5 CPU. I'm pretty sure, and I guess the math would maybe add up there. Don't judge me if my math is terrible, but I think we're somewhere in the realm of 1.5 CPUs, right? And then obviously I'm using some stuff up with like system resources. You can see, actually just look a little bit higher there. We've got Canal node, we've got kubedns, we've got kubeproxy. A lot of vendors will ship their containers, their workloads with the allocated CPU and or memory set in the manifest. And I personally kind of think that's the best practice, like, because you want to be able to drop the workload in, especially something that's as critical as, like, in this case, Canal node, which is going to be working on the networking. And you want to know that it has a consistent amount of resource available to it no matter where you deploy. That way someone doesn't deploy it and it's best effort and being thrown off and all that kind of stuff. So cool. We've got, so we've got some resource on this node. That's the simple way to put it, all right? So let's look at our workload here. All right, so I've got a folder. Here is where I put some of the manifests that we're going to play around with today, at least for the app, I think, right? Okay, cool. So let's look at our very, very elegant application here. So the thing, I don't know, last night before I ended the day, I kind of thought, all right, well, what should I put together real quick that'll produce some load inside of Kubernetes, and as one would do, let's just make a loop that counts up, assigns a variable to a value as it counts up. We'll have it print, and then we will have it go ahead and write a response to us, right? And actually, that write line is totally wrong. I didn't update it, but it doesn't matter. We can get junk back. I'm more so interested in the status code we're going to get back. So those of you that aren't as familiar with Go, just think of this like a web server that will receive traffic, and every request it receives, it's going to count to this number, right? And then it's going to respond to the client synchronously. So count all the way up, respond to the client. And what we should see if all goes well here is as we start sending some load into this thing, we should theoretically see some usage go up from like a CPU standpoint in this case. So our focus will be very CPU focused in this use case. All right. Okay. So the only other thing I want to show you before we start deploying and we get to the part that I'm interested in, which is trying to scale this thing, I want to show you the metrics server. So as we kind of move along here, we're going to be looking at different ways you can determine whether you need to scale, right? And there's actually a couple different ways you can kind of integrate this, right? So if I do kubectl get pods for the namespace kube system, make it a little bit smaller here, still not small enough. Let's try that. Beautiful. You'll notice that in this sample cluster, I have deployed a metrics server, okay? So for lack of a better description for right now, think of this as a required component to propagate metrics about things that are running in my cluster. You might be familiar with, man, I'm already forgetting the name, Heapster. It's been a while. Heapster that used to do similar things as metrics server does. But I'm running metrics server in the cluster, which is enabling me to do some things that I want to be able to show you all. An example of that being, let's do kubectl get nodes again, right? And if I grab this worker node right here, command you're going to see me do a lot through today, assuming it works okay for us, is you're going to see me do kubectl top node, I believe, and then just the node name. Is that right? Okay, great. So let's make it cleaner here. So if I do this request, this is going to give me some data about the actual node. So kind of similar to what we had seen before. So it's letting me know, hey, you've got this node, okay? You've got about 3% CPU usage right now, right? Now this is my usage to be clear, right? These numbers won't add up to the numbers we were looking before because those were like the reserved, and this is my usage, right? So because I have metrics server running, I'm going to be able to run these commands and just get information about things like a node's usage. I should also be able to go in and do, let's grab a random pod from kube system real quick. So if I grab canal master, we will do a top on that pod, okay? And we will put the pod name in here. And now we can see our usage from a pod level, right? We've got canal master, 12M CPU usage, 68 MI memory usage as well, all right? So what we'll want to do here is get this app deployed that I showed you, and then use commands like this, use the data out of the metrics server to see how it gets impacted from all this good stuff. All right, so let's see if we can deploy this real quick. And before I do, just take a quick look at chat here. Cool. Interesting data from the metric server to compute that. Program stress. What's that project? Is that a way to give metrics, or is that a way to like stress test things? I don't know if I've come across that one, to be honest with you. Mystic, the terminal I'm using, is RxVT Unicode. It's one that runs on Linux. So it's just like a super basic terminal that takes a massive text-based configuration file. I love it though, because you can kind of tune it the way that you need. Oh, stress test. Okay, that makes total sense. So you're gonna get to see me use the lovely tool JMeter today. For those of you who remember JMeter from doing a lot of Java-based work, I installed it today. You might have seen, and it actually gave me nostalgia opening up JMeter. It's been so long since I've used JMeter that I was just like, you know what, I should install it and try using it for this. So we're gonna try to use JMeter today and see how it goes. But thanks for calling out that project. You all should check it out and see what you think. Maddie, Josh came up with something cool. I used -- command with while do done. That's also a great idea. Yeah, I mean, at the end of the day, we're not doing anything fancy here, right? So if we did like for I in something, or like you said, while in bash, all we'd have to do is say curl this thing, and you could even spawn multiple threads. If you did curl blah blah blah, right? Like for I in one dot. It's been a while since I've done these types of commands. Let's see if it even works. Do curl google.com. We'll DDoS Google here. Google.com. And then you could spawn off theoretically 40 threads, right? If you did ampersand done. And I think, great, yeah. So you can have like 40 concurrent clients to test out HPA to some degree, right? So you don't have to do anything fancy here, but that's a great call out, Maddie. You could keep it as simple as bash. You could be as fancy as using some tool as well. So great call outs, everyone. All right, let's deploy this terrible application and see how it goes. What do you say? All right, so I did throw a deployment together, and I was messing around with it a bit last night. So let's talk about this real quick. Okay, great. Yeah, this is pretty much the crux of it all. So again, I just wanted to save some time with like the container image stuff. But we'll start here as our starting point, and we'll just build from here. So just so you know, just to make sure you don't feel like I'm doing something fancy behind the curtain here, I've uploaded that Go file as a static binary in either a Scratch container or an Alpine Linux container. I put it up to, I think, Docker, definitely Docker Hub based on the image tag, and just put it there. Okay. So the things that I've started off with, I've called this app Counter, and I'm going to be using Contour during this demo too, so don't get the two confused. This is the Counter app, not the Contour ingress controller, okay? Very simple, as you probably saw in the Go code, and I've done the same thing on the container level. It will expose port 8080, okay? And then we'll have a resource limit, and something that maybe we should pause for a moment to make sure we're all on the same page and see if you all have any questions with this, right? What I'm going to do to sample CPU is I'm going to set a limit of 250 milli CPU. Is that how you say it? Someone correct me if I'm wrong. So basically, you can go to the Kubernetes doc and learn about these different metrics, but that's a TGIK in and of itself, in my opinion. Think of 1,000 as a CPU. If memory serves correctly, yeah, 1,000 should be a CPU. So I'm using like a quarter, I guess, of a CPU here, or at least requesting that much. But let's pause on this point real quick, okay? So chat real quick. I want to get another check with you all to see kind of your familiarity here, okay? So let's do this. So chat, tell me who has used requests in Kubernetes and or limits, okay? So what I want you to respond with here is tell me I've used requests before, I've used limits before, or I've used both, or I've used none. So just so I have a kind of a context of where you're all at. So again, answer in chat for me. Who's used requests in Kubernetes? Who's used limits? Who's used both? And then who has used none of those at all? Jacques, rename counter enumerator. That would have been a lot better, yeah. But we're not going to do it now, I don't think, because I'm just worried that I'll forget something that it plays with. But that's a great point. Okay. Both. Martin, you've done limits. Okay. Herman, you've done both. Does that mean like kind of sort of both? Cool. Good. Okay, cool. So it sounds like most of you have a conception of these things. So just to kind of lay the land out here, right? Cube is going to let us do CPU, memory, and more to some degree, and specify requests and limits, right? So it's more intricate than what I'm going to describe here, but I just want to lay the foundation, right? For requests, you can kind of think of this as like what the scheduler should carve out, okay? And the key word here is kind of the scheduler. So like the idea is like the Cube scheduler will say, okay, so you want to request this much CPU. I'm going to schedule you here. And like, I know from a scheduling perspective that like you're taking up this block of CPU, right? Now, the difference with requests and limits is generally requests are enforced at runtime, right? From like a C groupy type level. Now, there's actually some inaccuracies here for those of you who are like really deep in this stuff. But for simplicity's sake, like the limit on a CPU would say, okay, you requested a quarter CPU. If you start ramping up your usage, I'm going to be an upper bound that tries to make sure I keep you on some like check interval underneath or at that bound, right? So the limits are going to have kind of an impact, whereas if you just had a request and you scheduled, theoretically, it could use 90% of the CPU if it's available to it, right? Now, technically, if the host came under contention, there's things that would happen around like CPU shares that would ensure that like the CPU for what requested it would get it and things like that. So it's a much more deep topic. Like you should check it out. Zalando did a really great talk a long time ago, or maybe a year ago, I don't know, about like resource allocation. And if you Google Zalando resource request limits or something, it's a fantastic talk. They talk about their struggles with it, why they only decided to use requests, I believe, for CPU and not limits. And yeah, it's really interesting. And you can learn about like how limits are enforced with this thing in the kernel called the completely fair scheduler. Which is an apt name for what it's trying to do. It's trying to make sure that you don't use everything when you can and keep it fair. Anywho, there's reasons why you might use one or the other, and I just want to make sure you're all on the same page. Now, limits is what I decided to focus on here, right? And the reason I decided to focus on limits is because in the absence of requests, my request will become my limit. Because think about that for a moment, right? If you set a limit in place and you say, give me a quarter CPU, limit me there, but you don't specify a request, well, obviously it makes the most sense to just have the request equal the limit, right? So that's effectively what we're taking advantage of here. So that's my shorthand way of saying, give me a quarter CPU and don't let me have more or less. Everyone in chat good? All on the same page? Let's do it. Okay, so enough talking, and you're welcome to tell me to shut up too if I go too off course on these things. All right, so let's see if the deployment even works. So the first thing we'll open up a bottom buffer here. You all probably know I'm a huge fan of watches. So watch kubectl get pods for the namespace TGIK. That does remind me. Let me see if I'm making a TGIK namespace here. Oh, beautiful. Okay. Sometimes I think ahead. It's rare. But it happens. So kubectl apply deployment, right? Cool. Okay, counter, please run. All right, so we have got the counter running on the node, quick and easy. All looks pretty good. Cool. So now that it's running, we should be able to start sending some load into this thing and trying to observe what it has available to it, right? But let's just start off by trying to figure out what is available to it. So if we were to go into our counter here, right, and we were to say kubectl get, let's do a top actually. So we learned that we can do top pod, hit this, send in the namespace for TGIK, and currently our usage is 0M. So it's running an HTTP server in Go, which I'd imagine is pretty lightweight by default. We're not using any memory, nothing like that. We are using memory, of course, but like not a lot of memory. Okay, so let's do this. Let's make another watch, I guess. So in my top buffer here, I'm watching, and then in my bottom buffer here, I guess this actually isn't that important. So we've got our pod. We're looking good. Cool. So maybe we can start off, what do y'all say, with putting some load in here, okay? So there's some really cool cloud native tools to do this, but we're not gonna use that. We're gonna use JMeter, right? Let's boot it up here. Y'all are gonna laugh at my fiery burning obsession with JMeter. It's actually like borderline concerning. I probably should see somebody, but look at that interface. Like, have any of you used JMeter before? Like, I don't know, I hadn't used it in 5 years, and I just opened it up and was like, oh, I remember like trying to figure out why this JVM app was slow, and it was because this sync function was getting called when JMeter called this particular API. Like, I don't know, I've just spent a lot of time in this thing, and I hope I still remember how to use it. So here's what we're gonna do. And this could be kind of an introduction to load testing tools if you haven't used one before. That's kind of cool. So most load testing tools have the notion of users or threads. They usually mean the same thing. So to kind of start us off here, we're gonna start off with 2 users, okay? So these are people that on my computer will translate to threads, not real people. I don't have Steve and Jason behind the scenes like making API requests, right? But this will, when I hit enter, spawn off ideally, I think 2 threads, maybe in the JVM, and then shoot off requests to them. So our loop count, we'll just say forever. So as we start sending requests in and testing out these autoscalers, we'll use that, okay? And then for the request, if we go down to the, let's see, I think it's a sampler, right? We'll do an HTTP request, okay? And we're gonna send this HTTP request into the node, all right? Now, the one thing I do wanna actually introduce here now that I think about it, and I wrote up some manifests for it, so it should be fast. I want to introduce a load balancer, an ingress controller. So we're gonna deploy Contour real quick. I've already got some manifests for it. So I'll just kind of show you how that works real quick. So let's move our friend JMeter to the side. We'll come back for you, JMeter. Okay, so let's go ahead and see if I still have that file. Contour, cool. So I'll spare you the gory details of deploying Contour. It's not that important for what we're trying to talk about. So service Contour created, namespace created. Okay, good. Let me see what what is my Contour version I'm using here, actually. Let me just check that real quick. Okay, that's good. That's what I was expecting. Good. All right, so kubectl get pods for the namespace TGIK. Okay, great. So again, so you can see the similar names now. Here's the problem I was worried about. So Contour is running and Counter is running. Now, just to make sure you're understanding here, Contour, I've got it deployed with host port. So it's kind of like host networking, but it actually is a little different. There's performance reasons why you might use host networking. Nonetheless, what I'm trying to get at here is Contour is going to be attached to the edge of my node. It's going to consume port 80 on my node, and traffic is going to kind of shoot through and disperse to theoretically Counter here. So I also put up an ingress to save you some time from watching me write it. Is it still called ping YAML? Yeah, it is. Okay, sorry. So basically the idea here is if you send a request into this domain name on this path, we will send that request into any pods that are selected by this service. Okay, so Contour receives traffic, sends it to the pods, plain and simple. So we'll do a kubectl apply to ping YAML. Again, that should be probably called ingress YAML. And now we should be able to send traffic in, okay? So let's see if we can do that. And this is probably, if anything goes wrong, this is probably where the biggest issue will happen. So we'll just open up our counter one more time. Let's bring our friend JMeter back. I told you we'd bring him back. And let's go ahead and put in some data here. So the first thing that we need to do is we need to figure out our node, right? Because like I mentioned, I'm gonna have Contour running on the edge of one node, okay? Just again, for simplicity's sake. So theoretically, I just need to call this IP address right here, right? So we'll go back to JMeter, we'll put in this IP address. I've got Contour exposed on port 80 for the non-HTTP traffic, so we'll still go through port 80. I don't think I'll need to set a port number here. Path is fine as is. We're gonna trick the test though. If we go here and do a HTTP header manager, because I don't have DNS set up in the request, we're gonna set the host header to be the value of that YAML I just showed you, right? So this is kind of like setting in an Etsy host on your system, if you've ever done that before, to make a host auto-resolve to an IP address that you specify. We're not doing that. We're basically just going directly to the IP, but setting the header, so when it gets the request, it's like, oh, you asked for this host name, blah, blah, blah. So if we go into our manifest here, let's do a cat on, what was it called? Ping, right? Ping YAML. We'll grab the counter here. We'll bring our friend JMeter back, and we'll put the value in. All right, so there we go. We've got host, we've got the host name, and we've got that as part of the HTTP request. And I think that's the right level to have it on. Host, good. Okay, cool. So that should hopefully send some results in. Now, another thing that we'll do here, let's go ahead and I think I actually put it in the test plan maybe if I want it to be used by multiple thread groups. I can't remember. Anyways, so we'll go into the HTTP request and we're going to add in a post processor, or sorry, is it a listener? Yeah, a listener that gives us a summary report, which I think should tell us if things are failing or succeeding. And then we'll go in and add in one more listener, which will give us graph results. Yeah, that seems pretty good. And actually, there's a response time one. Let's see if that'll work for us too. So response time graph. Cool. Okay. So there's our requests. This is all good. It's looping forever. Now, if I execute this right now, we probably want to do some amount of like throttling on it, right? Because we don't want it to just go crazy per se. So we're going to go in, and I think we do it on this level. We'll find out soon. Actually, you know what? It might be on the thread group level. So we want to put in a, let's see where it's at. Should be not a timer. No, it is constant throughput timer. There it is. So our target samples per minute, let's start off low here. Let's try to do 10 samples, 10 per minute on each thread though. Yeah, this is where it always gets you confused, right? We'll start lower. We'll do 5 requests per minute on each thread if the service can even respond to that, right? Remember, we're doing a big loop here, okay? So we'll do it on this thread, and I think maybe it needs to go in there. We'll see what happens. Okay, all right, chat. What do you think? Will it work on the first try? Will we be able to start trying to auto scale based on this? Let's see if it works. Good. I'm glad some of you share my nostalgia with these Java-based load tools. It's pretty cool, right? Okay, let's see if this works. So we'll send some requests in. You should save your test plan. Okay. And we'll call this the important test plan. All right, cool. It's running. Summary report. All right. We got throughput and we have 0% errors so far. That's good. So while this is going, let's make sure we have our top window up here set up with top again. Cool. So we'll keep that on. Now, and we got some load coming in too. That's good. All right. So we're really starting to set the stage for how things are going to scale pretty soon, right? So it looks like our app is not struggling too much when the throughput is in total, at least so far, it looks like the total is 12.3 per minute, 10.3 per minute. But obviously we're just starting, so it could be a little unstable. This graph will show better stuff in the not too distant future. Okay, and then we can see our response times too. So yeah, probably just the initial kickoff, and then we're kind of trending down. Okay, so based on this initial metrics, it seems like with the usage of 61 millicPUs, we can satisfy this amount of requests. Okay, so there's really no need for scaling so far. All right, so if we go into the thread group, and what do you say we beef it up? What do you think, chat? What should our thread count be here? I'll let you ponder that. So let me know in chat. What do you think our number of users that this app can take on? Oh, actually, it looks like if you look in the top there, looks like our CPU is increasing a little bit, huh? So we're maybe a little bit too quick to judge. It's starting to take a little bit more load. All right. So while you're thinking about the number of threads, I'm going to go to the throughput because that's actually what matters here, right? At least per thread. And then we'll bump this up to like, let's say 25 maybe. And then we'll bump our thread counts up to, in this case, just 5. So while you should do this scientifically, I'm not going to. We'll stop and we'll hit run again. Let's clean the results out too, and we'll keep our summary report here. Okay, cool. All right, so basically what I want to do here is obviously create some stress, and you can already see it starting to pop up. Create some stress on the pod, and then what we'll do as a group here is we'll start playing around with pod autoscalers in hopes that they will drive cluster autoscalers. Okay. So fingers crossed. Give it a sec, because the metrics API is probably just getting propagated with new objects or updated data, if you will. But I would expect, with as big of a jump as I just did, that this will probably hit 250, which again, remember, that was our max milli-CPU. Unless I underestimated our app and it can handle more than that, which is, I suppose, not too impossible. But you will notice here that it probably isn't handling it, because the error percent right now is not 0. So clearly something is failing in these requests here. Okay. So while that's going, we'll let JMeter and the pod counter kind of get some data. There we're 250 now. Okay, so we're maxed out. All right, so let's talk a little bit about horizontal pod autoscalers. That'll be our first place to start, right? Horizontal pod autoscaler. Okay. So the horizontal pod autoscaler, as the name implies, is going to scale your pods by adding new replicas of them, right? And it has a bunch of different ways that it can do this. If you look through the docs, one of the basic way that it can do is it can just use kind of the default metrics API and pool data that Cube already has about the, or in conjunction with the metrics server, it already has about the usage on that particular container or pod, right? And I saw some of you talking about algorithms, although I think it might have been like specific to ABC's usage, if I read the chat quickly enough or correctly. But there's algorithm details about how it does the calculations. So it looks at our current replicas, right? And then it multiplies that by current metric value over desired metric value. And then that can determine what it thinks the desired replica should be at a given time, right? So the big thing to know here is, like, if I didn't introduce an ingress controller and I was just feeding into one pod and my like expected utilization was limited at 80%, if I scaled it up, scaled it horizontally and introduced a new pod, then like as the requests came in, right, that other pod, if it's not being hit through the ingress controller or balanced to, it's not going to take any utilization, right? So HPA is going to realize, all right, I only need to scale it by one replica, and now my overall count percentage-wise is even way lower than 80%. It's not just going to keep scaling, right? It's going to need to calculate that based on, you know, your current usage of the pods that the HPA is looking over. So somewhere in here, there's a command where we can set up kind of a shorthand command to get you started. Here it is. I like this one. Kubectl autoscale. Okay. Now, an interesting thing about this command, I'm pretty sure that this is correct, and someone in chat can correct me if I'm wrong at all. But if we introduce a horizontal pod autoscaler, okay, to our replica set here, I think how this works in Cube is, if you have a deployment managing the replica set, you need to point the autoscale at the deployment, or else the replica set, the deployment will just like keep resetting it. I'm not exactly sure how that works under the hood. It's an observed behavior that I've had before. So we're going to do an autoscale on the deployment, okay? The deployment we know, because you can always look at your pod, right? This is your deployment name. This is your replica set ID, and this is your pod ID, right? So we can kind of look at that and figure out what's what. So if we go to deploy and we do counter, okay, let's see. What do you think? So we'll do I guess our min should, let's do a min of 2, just so we can see that kind of bounce up immediately. We'll do a max of I don't know, what do you think, 20 pods maybe? And then we'll hit enter there. Do autoscale deploy. It'd probably be helpful if I put the namespace in, right? So TGIK, let's try that. Cool. All right, so we'll keep top going up here. Now, top might not immediately show the pods. It doesn't mean they're not creating. Like if I go in and do kubectl get pods namespace TGIK, no, another one hasn't created just yet. Oh, there we go. Okay, spoke too soon. But you can see how it's now respecting that minimum, but top isn't showing it quite yet because guess what? It's not taking load yet, right? So we still need the load to come into this. It needs to, if it has a readiness check, it needs to pass its readiness check so that traffic can come in and all that good stuff. So that's all fine and dandy. We'll wait for top to kind of show it up here. But let's look at what that manifest kind of looks like, right? So if we do a kubectl get pod, no, get HPA, sorry. Get HPA. In fact, I'll even show you a simplified view of this real quick. Get HPA for the namespace TGIK O wide. Give it just a sec here. Cool. So you can see some interesting data here, right? First off, we've got an HPA now. It's a counter. And I guess one thing I should have unveiled is HPA is a controller, like a lot of other things, okay? So if you haven't seen it, Duffy has been doing awesome sessions on grokking Kubernetes where he dives deep into this stuff. And I think he's already done controllers. Someone correct me if I'm wrong if he hasn't, but you should check out that TGIK. It's awesome. A controller, right, that is being used here is actually HPA. So I didn't install anything to run HPA per se, right? I'm just using Kubernetes. The counter is set up. You can see that it's letting me know that currently I'm at 100% out of 80%. So on the interval that it's going and checking and trying to make scaling events happen, right? It realizes that scaling is needed at this point. There's probably a little question about that. We can see our min pods, our max pods, our replicas, and all that, right? Now, this is, I guess, more so just to feed your interest because we won't have time today to get into it. But you can do fancier stuff than what I'm just doing with CPU, right? One of the things that maybe if it's interesting to you all, we could dive into someday is talking about kind of tuning this. Like there's the whole notion of like cooldown and delay. You don't just want to just start blasting resources everywhere and DDoSing your whole system. There's notions of using more than one metric, which I'm obviously just using CPU. You can use custom metrics, which is something I'd selfishly love to dive into, like triggering off of other things and all that good stuff. Additionally, I think I was looking at it last night. Maybe it's this one. There's some examples just to kind of show you. Oh, hey, look. They did the same thing we did. That's funny. Okay. Anyways, let's see if there's another load piece here. Stop load. That's CPU as well. I'm looking for an example that's not CPU. There we go. So you can kind of see where this can head, right? Like potentially packets per second could induce scaling events. It's really like, I guess at that point, a business and technical question on an app side. So like CPU is an easy thing for us to model, but you can get much fancier with like what you're looking up and the events you're scaling on, right? So cool. Okay, good deal. So let's go back and let's see what we're scaling up here. So if I do kubectl get pods namespace TGIK, whoa, we're scaling. Okay, this is good. So we're starting to bring more and more pods online. All right. And we should have, I wonder if this pod's stuck. Yes, okay. We might have a lucky / good transition here. So why do you all think this pod is stuck? So what do you think, chat? Why do we have a pod stuck and pending here? What do you think's going on? So HPA is saying, pod, come on, create, right? And the pod's just stuck, right? And yes, you could have guessed. So what's interesting, or ABC, yep, you're right, out of resources. So what's interesting about this, and going into kind of your answer, Ramesh, which is probably not exactly what you're thinking, so I'm just gonna misconstrue what you're saying. It kind of has been scheduled, right? Like it knows go to this node, but you're out of resources, right? So you've hit the, do we still have our ugly diagram? Let's see. Yes, we do. We've hit the limit on these bigger boxes, right? And we're obviously at this point missing our friend down here. So, if we went to Amazon, I don't think we would see like 100% CPU usage on this node, right? Although we are hitting it pretty hard right now. I guess it would depend on how it's sliced up. Anyways, we know for sure that, but from a scheduling perspective, we've sliced out more than we want to schedule on top of, okay? So thinking this through, how can we kind of check it out? One thing I'm not sure, I wonder if HPA tells you in the event API that this is hitting a scaling limitation. What do you all think? I know it'll tell you on the pod level, but I don't know on the HPA level. So what do you say if we do a describe HPA, let's see, describe HPA namespace TGIK, successful rescalable, new size for, okay, so I actually haven't looked into the events of the HPA yet, which is clearly extremely helpful, right? So it doesn't know that the pod couldn't get scheduled, it seems, which is totally, I can reason with that because like, it's not the HPA's concern really, like whether there's infrastructure for the pod, right? But it is cool that it tells us here like, hey, I wanted to scale up because based on your rules, I felt like we were above the CPU CPU limit that you had set, right? So what we can do with the pod is we can go in and take a look at it. So let's try that now. kubectl, get pod, namespace TGIK, and we'll describe pod here. Cool. All right, so this is probably a message those of you who run Kubernetes have read 1,000 times over at this point for various reasons, right? It's one I always see, and it sometimes confuses me. So what it's saying here is, I looked at 0 out of 2 nodes, okay? One of them had insufficient CPU for scheduling, comma, the other one had taints that this pod could not tolerate, right? So what this is saying in plain English is, I tried to go on the node that you're putting everything on, and I don't have CPU. And then it's also saying, I also looked at your master node, but it's got taints on it that say it's no schedulable based on this role master, right? So I'm not going to land there either, right? So let's go ahead and see if we can scale out our worker fleet here, all right? Now, here's where we're going to try to bring it all home. So let's see if we can do this, everybody. So if you're not aware, there is a project. If you type in GitHub cluster-autoscaler Kubernetes, I guess that probably would have worked, but let's try Kubernetes. Autoscaler. Okay. All right, cool. Now, inside of the Autoscaler docs, there are different cloud providers today, right? And this is something that has to be, because if you think about it, to scale the cluster, you need to talk to Amazon. But wouldn't it be nice if the cluster autoscaler only had to worry about the logic of needing to scale nodes, but not how to talk to the infrastructure provider? So let me leave you with that cliffhanger there. Think about that for a moment. Like right now we have to have all these different docs and all this different stuff, but that's mostly because like how it talks to AWS is obviously going to be different than the API that Azure exposes. Okay, so let's go in here real quick. Cluster autoscaler AWS. Like I said, last time I touched this thing was in like 1.6, so we'll see how it goes. I looked at it a bit last night, but we'll see how it goes in a real cluster. So we want to scale our cluster out horizontally now. Fair? So okay, we need an IAM policy for the node group. That makes sense. What do you all think? Are you betting people? Do you think I already have my IAM set up correctly? Should I just skip this? Let's just skip this. We'll see what happens. AWS credentials. Okay, that's probably if you're not using an IAM role attached to the node. Okay, cool. Now, here's where it gets interesting. And I saw something in chat that might have looked similar to this. I don't know, ABC, if you had brought it up, maybe you were talking about something different. But you might need to run multiple ASGs. If memory serves correctly, one of the, should I say, limitations of cluster autoscaler in AWS, if I recall correctly, is that like, if you schedule a node, a pod somewhere, and it has an EBS volume attached, and again, chat, keep me honest, I'm not an AWS expert. The EBS volume is going to be in that availability zone. So if you have auto-scaling groups that span availability zones, I think one of the things you can theoretically run into is an auto-scaling event occurs and it starts a node in a place where things might not be available that you expect, things like EBS volumes or other things. Let's see, actually, let's just look at the docs. It probably says it here. Availability zones. Cluster Autoscaler does not support multiple availability zones. Instead, there we go, okay. Instead, you need an ASG for each availability zone, which makes sense. So Cluster Autoscaler can control those multiple ASGs, but it needs independent ones, because Cluster Autoscaler is going to be like, oh, you need to scale. Go to the ASG API and increase the node count, right? And it can't do that in an ASG for whatever reason that spans multiple availability zones. And those of you who aren't Amazon people, just think of availability zones like data centers that are not physically in the same place, right? Okay. So let's deploy this thing. I want to put this on my master node because I don't want this to take up room on my worker node. So let's try this real quick. Examples, cluster autoscaler. Okay, let's get this manifest here. Okay, so cluster examples, cluster autoscaler, run on master. That seems like a pretty good name. We'll grab this. We will bring this down locally. So let's call it cauto.yaml. Oh wait, let's wget it first, right? And then we will rename it cauto.yaml. Okay, cool. All right, let's take a look at this, everyone, and see what we can come up with. All right. So cluster role. We got just some RBAC, cluster role binding, deployment. Okay, here's what we want to look at. So we've got cluster autoscaler. Looks like it's got some Prometheus metrics that it exposes. That's good. Our image is right here. Okay. And okay. So what's interesting about cluster autoscaler, and I guess I had forgotten this detail. Those of you who have played with like Kubernetes CSI or cloud providers, you probably know, like, at one point we baked a lot of cloud provider logic into core Kubernetes. And with the introduction of CSI and for some other good architectural reasons, we've since extracted cloud provider logic into cloud provider controllers, if you will. I think, what is it, CCM, Cloud Controller Manager. And what's interesting about this is kind of using sort of the old model to some degree, in that if I'm reading it right, it looks like there's one single image and you set a cloud provider flag. So like, we're going to be running this in our cluster, and I'm guessing it probably has the logic and code for like Azure in it, even though it's not live, right? Which is kind of an interesting thought. So cool. Anyways, that's just me on a soapbox. This thing also has limits and requests, which we talked about are important things. So that's great. All this looks good. These can't be right. So let's do nodes 1 and then node max 20. So this is going to be probably my min and max. I think what'll be interesting here, and I'll take guesses or knowledge if you already have it, but I've already got an ASG, right, which is down here. And with this ASG, my min and max is 1 and 5. So what do you all think? What do you think, chat? Do you think this will get updated based on this deployment? Or do you think there's kind of two levels? I need to change it in AWS and change it in the cluster autoscaler. Yeah, so kind of a interesting thought to noodle on there. I guess we'll learn soon enough. And then the name of the ASG, I guess. So I think I do remember this being the actual name and not like an ARN or anything. So we'll grab this name. We'll paste it in. Okay, that all looks good to me. What do you think, chat? Does that manifest look good to you? think we don't have any mistakes? I'm hoping so. Okay, I'm gonna deploy this real quick, and then I'll read through chat. And it sounds like you all are having really interesting conversations around just general stuff, but I'll see if there's any questions in there too. So I'll save that up for cauto. Let's go ahead and again, as usual, we'll do in our bottom buffer, I guess this time, we'll do a watch for kubectl get pods for the namespace kube system, which is where we're deploying. So that makes sense here, right? Does that make sense to you all? Okay, cool. So bottom buffer here should have all our deployments, and then I'll try to deploy this. So if I do a kubectl apply c-auto, let's try that out. So I'll deploy this, and I'm going to take a second to look through chat and see if anything interesting came up. Sweet. Okay, let's see. Okay. Yep, no more resource. Yeah, I love the fear face there. It is definitely a full Tetris box. Schedule tries to take place. ASGs. Awesome, ABC. Thanks for all that context. I, while presenting, can't wrap my head around it all, but I will be going back to the chat to see what you implemented, because that looks, it sounds really cool just from the initial stuff. No version 116. If that's in regard to me, Herman, I don't know. What version am I using? Am I on 114 or 115? I just used a tool to bootstrap this cluster real quick, so I'm probably just on an old version. There is definitely a version 116. Cool. And then it looks like the rest is just implementation details. Very cool. So I guess, yeah, another big thing about kind of understanding this is you might not find this auto-scaling model works for you, right? Like, this autoscaler, as you're going to learn, is going to be based on an inability to schedule due to lack of resources. There are other reasons why you might scale. And a lot of my customers, when I talk to them, we actually talk about building something that does this. It sounds kind of like with your use case, ABC, where it was like, yeah, this is nice, but like we need to think about this more strategically for our needs and scale based on that, right? So a lot of times these controllers aren't that hard to implement, right? You just take a library like Cube Builder, right? Or just a client Go or whatever, and you just build a reconciliation loop that checks the logic you need and determines whether to talk to the cloud provider in scale or whatever in scale. All right, did this work? We're pending. Okay. My YAML skills failed us. Let's see what we got here, everyone, okay? Kubectl gets pods for namespace cube system. This one, I guess describe. Let's look at the events. So we'll describe this pod real quick. Oh, it doesn't match the taint. Okay, that would be an important thing. So same error from before, but for a different reason, I suppose. So if we look at c-auto here, and let's find the taint that it tolerates. Tolerations, yep. Okay, that's all good. That looks fairly normal. Let's see here. So if I do a kubectl get nodes, role is master, and that's the right key. I know that just from doing cube stuff. Let's describe this master node real quick. So kubectl describe node here. You know what? We're going to get the YAML. That'll be easiest. So let's get node. YAML. And let's, this is Silver Searcher, if any of you have ever used it before. It's freaking awesome. I think it's actually one of my old coworkers at CoreOS who wrote this, or a couple of them or something. It's really, really performant, but think of it like grep. And we're going to ask for AG for after for I think the keyword taint will work. What's the issue? No, our key is different. Check that out. So maybe this is actually a version mismatch thing, or just someone chose to use a different key. So the taint key is supposed to be this, it looks like, right? So let's go back here and, oops. Oh, geez. Okay, cool. And let's do that and bring in node alpha Kubernetes. That looks good. So that's the key. The value is master, it looks like, and equal. Effect is no. So that looks all right. Yeah, what do you all think? That seems better for the cluster autoscaler. So let's see if that works okay. All right, cool. So we do a kubectl. I'm usually a fan, just to make sure I'm not on a back off for these types of scenarios. I'll start off by deleting that, right? And then we'll do a kubectl apply c-auto. Create it again. All right, let's set up our watch. Cool. Oh, interesting. Rest in peace grep replaces AG. Is that a competitor, or has AG or Silver Searcher decided to go to RP grep? I've never heard of RP grep, so That's cool. If there's something even better, I will check that out afterwards for sure. Oh, it's in Rust. Wow. Yeah, that is bleeding edge. I like it. Cool. I'll check it out for sure. Awesome. Thanks for the heads up. Okay, so it deployed. Okay, we're maybe getting farther this time. Run container error. What do you think it is? So kubectl get nodes. This node, describe node, right? So let's describe node. Oh, geez. Kubectl get nodes. We'll copy. No, wait. Actually, sorry, everyone. Let's do kubectl get pods. That'll be easier. For the namespace cube system. We're going to grab the autoscaler, and we will once again do a describe. So describe this pod. That's this one. The namespace is cube system. Etsy SSL certs. It's trying to bind to get the CA certificates. It's probably not looking in the right place. So kubectl get node. I bet I know what this is. cauto.yaml. These nodes are CoreOS nodes. CoreOS puts this in the CA certificates location. Oh, hey, how did it know that? Oh, that's weird. Because above. Interesting. So the mount path that it put in the container is CA certificates. Okay, anyways, let's try that. I think it might be as simple as that, but it's been a while. I don't even remember where CoreOS necessarily puts that. Okay, so again, let's do a delete. Okay, then let's do an apply. Okay, and then let's watch. Hey, look at that. We're running. That's exciting. Okay, so we're almost there, everyone. We're almost done, at least for this first session. So let's make this work. So all we got to do is see some nodes scale. Let's start off with logs here. So if we do a kubectl logs, make this a little smaller. Kubectl logs, no, an error. Okay, let's see what's going on. Kubectl logs for this pod in the namespace cube system. Well, it looks like we were wrong, everybody. I'm sorry to say it. Do you remember? Let's see if I can find it. Remember when I was in here and I said, hey, do you think I need this? And I said, nope, I probably don't need this, right? Yeah. So what I should be using here is I should be using a thing that delegates in a more secure fashion my IAM access, right? So ABC, exactly, kube2IAM. I know I'm saying it wrong, so someone correct me if I am. I think it's Kayam. I'm probably saying it wrong. Anywho. So I should use something that is going to provision this IAM role for me. But because I'm stubborn, like when I try to put together furniture and stuff, I didn't read the instructions and I hosed myself, right? So let's go ahead and let's add this in. So we have a statement here. I'm not going to introduce kube to IAM, just to warn you all. I'm sorry to give your hopes up, or Kayam for that matter. But I am going to go into my node role and do something that I probably shouldn't. So let's go to instances. Let's go to node. Where's our IAM group here? IAM role. There we are. Okay. IAM role. There it is. It's been a while. Sorry, AWS UI. Edit policy. Okay. Okay. It's still somewhat intuitive here. So, it was there though. Oh, you know what? That was my worker node, wasn't it? Let's go back. That's my worker node. Yep, I can see it from here. Excuse me. Remember, we're deploying on top of our master nodes. So let's check that one real quick. IAM role, policy, edit policy. Okay, let's introduce this here. So theoretically, if we come in, I'm guessing it's as simple as that maybe. Seem okay to you all? I'm going to go with it. Review policy, save changes, back to our terminal. All right, what do you think? If we delete this pod, will it work? Can we wrap this thing up on a good note? Let's see. All right, so autoscaler, kubectl, delete pod, namespace, cube, system. Okay. Just looking at chat as that deploys. Oh, Nadir, hello. Similar to Steve, Nadir used to be on Duffy and I's direct team, but he's moved more into engineering stuff. He does awesome work in upstream. Super glad to have you towards the end of this, Nadir. Welcome. You can right all my wrongs as I mess things up. Hamal, would you mind explaining why you did delete and apply? Yeah, I did delete and apply because like I'm weirded out by like things trying to like delta change on top of each other. Although Cube is really good at that, it probably would have been fine. Like sometimes I'll apply or change something, but the pod is still in a crash loop back off. So it's more so that for this example, I don't die on the hill of a paper cut, if that makes sense, right? It's not what you should do per se in a real environment. It's just what I'm doing. Cool, Herman, you put in the policy JSON. Cool. Yeah, all right, good deal. So, and you guys just explained that in chat anyway. So thank you for backing that up. I should have looked down and read that. Hey, we're 72 seconds in. This is promising, right? I think we can ship this thing for production. Okay, so let's see the logs now. kubectl logs for the autoscaler. Logs for this. Namespace is kube system. Okay, this looks fairly healthy to me. Let's go ahead and tail these logs out, and we'll just keep an eye on it. So I wonder if it'll pick up the need to do a scaling event automatically. Scale down status we can see here is unneeded. Starting main loop, 1 unregistered nodes present. I'm not exactly sure what that means. Maybe that means it's, ooh, look at that. Upcoming 1 nodes. I wonder if that's a scaling event based on our load. So let's bring our buddy JMeter back in because I've missed him. It's been so long since we've taken a look. We're still at a 2% error failure. There's lines that have colors that apparently depict that our throughput and such is stabilizing a bit. Okay, so let's see what we got here then, huh? So if I go down to Amazon, let's start there. So obviously, like the scaling event will take some time because we got to stand up the node. There might be user data that needs to run, blah, blah, blah. The kube components need to initialize. But let's see what we got. So we go to EC2. Oh, I think that number is a good thing. Check it out. Success. Exciting stuff. Look at that. So I hope you're all as excited as I am. So we have a node that's kicked on. It's initializing. If we go back to our tests here, I think we should see a decrease in our throughput eventually. So there's a couple, I mean, we already saw that log line right up here. I think it said like upcoming 1 nodes. That was cool to see. If we clear this out and then we do kubectl get nodes. So let's start by watching that. Oh, check it out. It's registering in cube, 7 seconds, good deal. We'll make a couple things here. So let's do that. Let's set up a window that's going to be dedicated to watching the top for pods inside of the namespace TGIK. Wait, top. Oh, kubectl would be helpful, huh? I don't think just top is going to do the trick. Okay, so we've got these pods here. This bottom one, let me just bring that down a bit. Okay, so again, we're in the 3 pods, and then down here we'll watch kubectl get pods for the namespace TGIK. Get pods. All right. Oh, hey, that one initialized. So that would make sense because now our extra node is ready. Okay. So we talked about kind of the multiple factors here that are in play. I think what I would expect, and let me know if you all agree, I think what we should have happen now is HPA should continue to be able to kick off, right? Because there's no longer that inability to schedule. So there's no longer that node that's or that pod that's taking 0% CPU. So I think we should start see scaling events on our pods. And if that new node fills up, we should then again see another scaling event on our cluster if all goes well, right? So we'll wait for that for a sec, and then we'll wrap all this stuff up in a bow and call it complete for Friday. So that all looks good. Our pods. Oh, check it out. I don't think we're hitting it hard enough anymore, are we? So you can see we did what we wanted to, we scaled out, and our utilization has dropped down. So, all right, enough of this child play, right? We're gonna go all in. So, by the way, I'm running JMeter locally on my machine. You would never do this in real life. So I'm gonna introduce 20 threads. I am gonna put my constant throughput timer up to 100, and let's get crazy, okay? So this is on each thread too, by the way. So like the factor to which we are going up here is kind of ridiculous. So we'll stop, we'll start, and let's see what happens. Summary report. All right. So this guy's running, and pretty soon here, I might have just DDoSed my entire thing. Oh no, it's moving a little bit. It's moving. So it should be feeling pressure again pretty soon here and scale up. All right. And then Herman makes a great point here. One thing that I hadn't mentioned is it also should scale down, right? So once I kill JMeter, and for some duration of time, it's starting to realize, hey, I don't need these nodes anymore, right? It actually should start taking the nodes and scaling them down. Now this is, one thing that operations oftentimes like, if you have a dev cluster. One instance I set up was we had a dev cluster, and we used a project, speaking of Zalando, similar to Cube Janitor, is that the name of it? Where you basically put like TTL annotations on your pods. So what would happen is when you were just using like the test dev cluster, on some interval, it would just wipe out deployments and resources. That way we weren't just like letting a bunch of stuff sit around, right? And then what would happen there is, let's say an event would occur on night, it would sweep up a bunch of deployments, they would go away. All of a sudden there'd be underutilized nodes. So we were running cluster-autoscaler, and cluster-autoscaler would realize, oh hey, I can start killing off nodes because I no longer have that pod resource utilization that I used to need, right? So that's kind of a cool thing to think about. Ooh, check it out. We introduced a new node. So that's good. We're clearly hitting it harder than we otherwise expected, right? So that should be scaling up as well. So I will let me wrap this topic up while we see if another node comes online with cluster-autoscaler. Oh, you know what? One thing we meant to check, I had mentioned to you all because I wasn't sure of the answer. If we go to autoscaling groups, okay, yeah. So it didn't change the min and the max based on what I said in the manifest, right? Which might actually be a good thing. Maybe you do want that kind of separate, kind of level there, right? You want your AWS level to have a min and max, and you want your manifest to have a min and max. But now that we're talking about this, I actually remember Autoscaler has like a discovery mode or something. Let me see if I can find it here real quick. So if you are actually going to play around with this and deploy it, I think this is the way to go, if I recall correctly. Auto discovery mode, I'm pretty sure works off of an AWS tag. So what you can do is you can set that min and max in one place, right? Inside of the AWS console. And then auto discover, it will see the tag for that ASG, and it will just automatically respect those settings. So you all probably saw me go in and I put the name of the ASG, I put the min max of the ASG. Auto discover, if your tags are correct and you have the right privileges, should automatically be able to detect those and then just start controlling those ASGs. Simple as that. So that's kind of another approach that you could take. And look, Amazon's trying to help me save money on compute, which we're effectively trying to do to some degree here as well. Although I guess we're actually spending more at this point, right? Okay, so we still have this many. Let's go back to our JMeter piece. We are scaling up though. Check that out. More and more pods. I think we're going to hit it soon. So let's talk about one more concept before we end the day here. So, kind of the last thing that I wanted to talk about is that this auto scaling model is something that we can deploy. It solves a common problem. But one of the things that I think is kind of interesting about this is that the autoscaler needs to know about how to talk to the cloud provider, okay? So paint this picture with me here and see if this resonates with you. And we have Nadir, who knows Cluster API really well, so he can help me out with gory details or thoughts. But what I'm excited about is something you've probably heard about on this channel quite a bit, which is how things are headed towards a declarative model in regards to how we manage the life cycle of clusters, right? So The thought process being, for those of you not that close to Cluster API, is, and it's more complex than this, but think about it like we can have a cluster that understands how to talk to the infrastructure provider. And as you add manifests in, just like you do for any other resource in Kube, you could actually put a manifest in that like basically kind of describes a cluster, right? And then that thing could ingest and be like, okay, cool. So like a couple nodes, you need this, that, the other thing, you need this pod citer, and it can actually go out and talk to the provider and instantiate clusters. So it's like Kube instantiating Kube, and then Kube to some degree managing Kube, right? Actually, let's go back to our terrible diagramming tool, since that seems to be our jam here, and let's introduce a new one here. So think of it like we have this cluster API thing, right? Just think of it like some nebulous thing right now, okay? And this is, don't shoot me. I'm not trying to be technically accurate here. But basically, as we go in and we submit manifests, right? These guys, okay? We'll give it to Cluster API, and then Cluster API will be able to instantiate and manage Kube clusters. So this is Kube cluster 0. This is Kube cluster 1, right? Now, the great thing about this model is that you think about where does your cloud provider logic exist, right? Well, in this case, if you implement a provider, like let's say an AWS provider and or a vSphere provider, right? What this means is as you put in these declarative manifests into cluster, via Cluster API, into this cluster, right? Let's call it a management cluster, I guess, for lack of a better word. I might be calling it the wrong thing, but it can then understand like, oh, you want this thing, and I'm the vSphere provider, right? I know how to make that happen in vSphere. I know how to make that happen in AWS. So it can go out and it can actually add new Kube clusters and manage them. Now, where this is headed, right, is think about if you wanted to add a node. You don't need to talk to Amazon to add a node anymore, right? How did you add nodes in the first place? Well, in this model, you used this declarative API, right? You used this YAML manifest that apparently you like physically handed to some cloud, right? And that cloud is a Cluster API cluster. And that manifest can say things like, give me 3 replicas of nodes. Let's to use common terminology here, right? Give me 5 nodes, 6 nodes. And just by increasing that declarative count, the CAPI, the Cluster API provider you have, can actually make that happen on a vSphere or AWS level. Now, why this is cool and why I'm bringing it up is I actually think it's going to introduce opportunities to simplify the concerns of cluster autoscalers. So ABC, remember your talk about like, oh, we're doing these custom things and so on and so forth to kind of scale up. Well, like theoretically, if you took that same need, but you kind of cut off your need to use like the AWS SDK to talk to AWS, and you literally just had to go into an API or to a YAML and basically increase the count. You take your replica from 30 to 32, and all of a sudden, that would happen from a Cluster API perspective and your cluster would scale. So again, it's kind of delegating those concerns to the provider and not having to embed cloud provider logic into an autoscaler. So I was actually talking to Joe about this before this TGIK, and he brought up a great point, and that is like, if we can move to this model in the future, right, where we centralize through a provider where the cloud provider logic goes in, kind of like what we did with like CSI stuff integrating with cloud controller managers, right? Then building cluster autoscalers will be so easy. It'll just be, it won't be implementation or provider specific. You'll be able to go in and be like, yeah, my business has like, is concerned about Black Friday and like these other random days and that's it. You can go write an autoscaler that's based on like time and date and these certain CPU nuances that you're used to seeing. And then instead of spending a bunch of time writing like reconciliation and retry logic against a cloud provider, you'll literally tick up a manifest, an API that says, I want 7 nodes instead of 6, and then it will just happen. So I'm hoping, because I'll be honest, I think there's been a lot of opportunity to do fancier stuff with autoscaling in Kube, especially building your own extensions. And I think if we can remove the need to implement the cloud provider logic, I think we're going to see a lot more cool, interesting stuff come out of the cluster autoscaler space. I really do. So I don't know. That's something to noodle on. I don't know, chat, if that resonates with you, but that's kind of an interesting thought about the direction that this all could head with our lovely cluster autoscaler diagram here and CAPI diagram. So check it out. Okay, I think we can wrap this thing up. So we've now introduced another node. So clearly we've scaled up. I will kill my throughput here now. I don't know, depending on if you all want to stick around. I know it scales down because I've seen this happen before, but I'm not sure how long it takes. I don't know what the defaults are. But theoretically, the utilization should go down, which means our pods can go down, which then means our nodes should stop being as utilized, and they should go down as well. If we look at our response time graph, you can see some of the initial requests when we really started hitting it. I'm just guessing here, but maybe this is where, it's actually hard to say. I was gonna say this is probably our initial hit, where our test results went when we added a node, and then maybe with 3 nodes possibly, but I don't think we've had 3 nodes online that long. So anywho, clearly we've seen this kind of dip and dip and dip and dip. So really, really interesting stuff. All right, so I'm gonna look at chat one more time. If you have any outstanding questions or thoughts, please let me know. Let's see what else we got here. Makes sense. 9 shout out. Cool. Yeah, you're right, Herman. This is all you'd ever need for Bitcoin mining. So be sure you set sensible limits, or else if a Bitcoin miner gets on your cube cluster, they're gonna have a lot of resources available to them, won't they? Oh yeah, one thing I had forgot to mention, and maybe if we ever do a follow up on this topic, we can dive deeper into it. I never talked about vertical pod autoscaler. Okay, so let me just mention it for a moment. There's VPA, which is vertical pod autoscaler. It's something that we could have used as well. Vertical pod autoscaler, as the name implies, is basically a way for us to scale the resources available to the pod vertically, right? So give it more CPU, give it more memory. There's really good docs on it. Check it out. I think your common use case with VPA, I actually haven't personally used VPA extensively. It's mostly been like my customers using HPA, but VPA is probably better for like stateful workloads where you can't just replicate, or maybe like it's a stateful workload where replication would mean the whole thing would have to replicate again onto a new node, and that's just not what you want to do. So just know that if you're scaling in the opposite direction, vertically, there is something called vertical pod autoscaler. It will let you set up rules not too dissimilar to what we saw here. Obviously, some of the big differences are we're not going to be replicating pods, right? And there's also some intricacies like when you add more resource, should the pod restart? Should it just expand if it can? Like what should that look like, right? So do be sure to check out vertical pod autoscaler. I focused on HPA here because it kind of played into the cluster autoscaler pretty well. Okay. So I think, everyone, that is maybe all we've got for today. So we succeeded. So again, have an awesome Friday. Thank you so much for hanging out. I hope you found this kind of interesting and informative to play around with. I would say, if this topic is interesting to you and taking it a step further as far as custom metrics go, making this fancier than just scaling based on CPU, add a ticket to TGIK and upvote it. I'll be sure to post in our internal TGIK Slack that we need to filter a little bit more by upvotes, because you're right. When they get to the second and third page, I sometimes don't look so much at them. But yeah, I can't thank you enough for joining us this week. Thanks so much for hanging out. And yeah, I'm sure Duffy and Joe will be back soon, but I'm sure I'll see you all soon in the future as well. So have a great Friday. Thanks again.